Welcome to Think Global Education Services. Today's topics will be collisions and types of collisions. So what is collisions? When two objects meet each other, then we can call that as collisions. For instance, let's just say two cars collide with each other. So we know that cars, let's just say cars look like this. So cars are going to collide. Then that is collision. Now there is a new design in the car which is made to prevent damage to passengers and the driver when they collide, and the design is called as the crumpled zone. That is, the crumpled zone is designed in such a way that the cars collide. It's a crumpled zone which is designed in such a way that it will absorb the kinetic energy of the cars when they collide. So thereby the kinetic energy is not transferred to the driver and the passenger. And this design is done by understanding collisions in detail. Now we have two different types of collisions. One is the elastic and another one is the inelastic collisions. So what is the difference between elastic and inelastic collisions? In elastic collisions, momentum and kinetic energy are conserved. In inelastic collisions, only momentum is conserved. The kinetic energy is transferred into other forms of energy. Kinetic energy in inelastic collision is transformed into sound energy, because when the cars collide, we can hear the noise of sound energy, sometimes light, and sometimes internal energy. Internal energy is nothing but heat. Internal energy is heat. Now, let us consider some other examples. Let us consider this is the surface of the earth and we have a ball. The ball is dropped, the ball will go and hit the earth and then it will rise up, but it will never reach the same height. So what is happening there? So this is happening because some amount of energy is lost here as heat, sometimes sound. So there is friction here, that is the cause for this energy loss. So the ball will never reach the same height, it will slowly die and will continue to jump up and down till infinity. Now, can we make any ball, or can we make the shape of the ball? Can we change the shape of the ball so that it will rise above its height? Yes, sometimes if we have a rugby ball, a ball which looks like this, a rugby ball, it is drawn in a different way. So if you have seen a rugby ball, yes, when the rugby ball is dropped, this edge, it is rotating. It rotates and it hits the edge, and then what happens is that the rotational energy is used to translate the ball to greater height. So that's a different types of process. Now here we discuss about only two types of collisions, elastic and inelastic collision. Now let us look at some examples for elastic and inelastic collision. Now, if you have seen a billiards board or snooker, at the ends of the board and also here too, there will be pockets. This is where we have to hit the ball. So we have a cue in your hand. A snooker player will have a cue in his hand, snooker cue, and with the edge it will be polished so as to hit the ball precisely. So here's a ball, a white ball might be here, and here is another ball. Let's give it some other color. Here is that blue ball. So now the red ball is going to be hit towards the blue ball. So we're hitting the red ball towards the blue ball. So what happens is that these two balls have the same mass. The same and here the same. And this ball is at rest. Well, this ball moves with the velocity v ball. And when the red ball hits the blue ball, the blue ball will move. The blue ball will move and it will go into the pocket. But what will happen to the red ball? Now, the red ball will occupy the place of the blue ball. The red ball will occupy its place. and it will not move. It will be just that. So what happens is that the velocity of the red ball, or the momentum of the red ball, is transferred into the blue ball, and the ball goes into the pocket. Now here, for this to happen, we need a very, very, very polished balls and the surface to be almost frictionless. But that is not the case. Even then, this process happens, because you can see that the red ball might have been here. It might have moved a little bit. So that is the case. Now we can achieve this with some ice cubes. That is, if we drop some ice cubes here, that is, we can put a layer of water and we can have 2 ice cubes floating on the water. We can assume that it is frictionless, and when we hit one ice cube with the other, the second ice cube will occupy the position of the first, and the velocity of the first will be transferred to the second ice cube. So this is an example of elastic collisions. Now, inelastic collisions. So in elastic collision, the example is car colliding with each other, or any other collision that happens anywhere in the planet. That is what we can expect is in everyday life there are many collisions, and all of the collisions are all inelastic. Elastic collisions rarely occurs, because kinetic energy will always be lost in some other forms. So this is the explanation for collisions and types of collisions, and how to identify elastic and inelastic collisions. And using the law of conservation of momentum, we can find out the momentum of the objects or velocity of the objects. If we know the velocity and the mass, we can find out the kinetic energy, which is useful to understand the motion and also the energy of the particles which are interacting in the system. Thank you for watching.